Welcome to the Explainer. Let's dive right into Microsoft Azure's big data ecosystem. Imagine, just for a second, a single tiny data point generated by a user clicking a button on a website. On its own, totally simple. But multiply that by millions of users every single second, and suddenly, that little data point is part of a massive, chaotic avalanche. So how do we capture it, process it, and actually learn from it without our entire system just crashing? Well, today, we're going to track the journey of that exact data point, moving from complete chaos to absolute clarity.
Here is our roadmap for the journey. We'll kick things off with the Big Data Challenge, explore the Lambda architecture blueprint, and then follow our data point through ingestion, real-time analytics, and storage, before pulling it all together into the complete system.
All right, Section 1, the Big Data Challenge.
To put things into perspective, Nathan Mars once pointed out that more than 30,000 gigabytes of data are generated every single second. And yeah, that rate is only accelerating. With the explosion of connectivity, smart devices everywhere, and hyper-detailed user tracking, we are looking at an absolutely massive demand for compute and storage infrastructure. The stakes for modern data engineering literally couldn't be higher.
Now, in the old days, data consolidation basically meant dumping everything into one giant relational database. But here's the catch. A single instance is always going to become a bottleneck. You only have so many CPU cores, right? And only so much drive space. Even if you try to distribute the tables, a process we call sharding, you're eventually going to hit a wall with I/O bottlenecks, and your query latency will just skyrocket. It becomes completely useless. And that is exactly why a new, scalable distributed approach, the Lambda architecture, became absolutely necessary.
Moving on to Section 2, the Lambda architecture blueprint.
At the very core of Nathan Mars's Lambda architecture is a brilliant concept. When new data arrives, it doesn't just get funneled into one place, it actually splits. It flows into a speed layer to give you real-time, low-latency views, and at the exact same time, it flows into a batch layer for deep, scheduled analysis. So the speed layer gives you those quick, up-to-the-second answers, while the batch layer takes its time crunching the master dataset to give you perfectly accurate historical views. Your queries then pull from both of these layers to give you the complete picture.
A super crucial part of this architecture is how it handles errors. Lambda architecture pretty much eliminates human error by relying on an immutable data set. This means data is written once, read a bunch of times, and never ever modified. You don't update existing records, you just append the new ones. It's a lifesaver because it prevents your data from getting corrupted by bad update logic. If someone writes a bad query, no big deal. You just fix the query and run it again against that pristine, untouched original data.
So how does the data actually get in? Let's look at Section 3, Ingestion with Event Hubs.
To get data into our system reliably, we clearly need a queue. Now, a traditional queue is first in, first out, or FIFO. Kind of like a single pipe, you drop a ball on one end, it rolls out the other. Azure Event Hubs, though, is totally different. It's more like a multi-lane highway. By using multiple partitions, you aren't stuck in a single line. You've got parallel lanes handling massive spikes in traffic all at once. This guarantees your system doesn't just freeze up when millions of events hit you all at the exact same time.
Let's break down why Event Hubs is such a game changer. It securely buffers all that incoming data, and it easily accepts standard HTTP and AMQP packets. But the absolute coolest feature? It has to be capture. Event Hubs can automatically grab batches of these incoming messages and write them directly to durable storage files as they are flying through the system. You literally don't have to write a single line of extra code to do it. It acts as the seamless built-in gateway.
Okay, on to Section 4, Real-Time Stream Analytics.
This is where we focus on the hot path. Azure Stream Analytics, or ASA, acts as a continuous reader. It pulls the streaming data straight out of the Event Hub's queue and processes it in near real time, running operations on a never-ending sequence of events. And once it calculates those rapid-fire insights, it shoots those aggregated results directly out to a serving layer, like a SQL database, or even straight into a live Power BI dashboard for you to monitor.
And if you're a data engineer, you're going to love this next part. To pull off all this complex, continuous stream processing, Azure Stream Analytics actually lets you use familiar structured query language, or SQL. You don't have to go out and learn some obscure new framework to define these real-time data transformations. You can just leverage the SQL skills you already have to tame the real-time hot path. Pretty convenient, right?
Section 5, Storage and Batch Processing.
So what about the cold path? For massive long-term storage in Azure, you generally have two choices. You've got Azure Storage Blobs, which offer petabyte-scale storage using a flat key value hierarchy. It's cheap, it's highly replicated, and it works great.
But for a true heavy-hitting analytics system, you are going to want Azure Data Lake Store. It acts like a Hadoop file system, complete with a familiar hierarchical folder structure, really fine-grained Azure Active Directory security, and honestly, virtually no practical limit to the amount of data it can hold. It is the perfect resting place for all our data.
Now, once our data is resting securely in that data lake, how do we actually process it? Enter Azure Data Lake Analytics. This service is designed to run those heavy, scheduled batch jobs over the massive files stored in your data lake. Because it uses a distributed query processor, it can execute jobs over multiple processing nodes at the exact same time. It reads the files, filters the data, crunches the calculations, and then perfectly saves the refined output files right back into the data lake. To write these heavy-duty batch jobs, Azure Data Lake Analytics uses a unique language known as USQL, and it is kind of brilliant. It takes the declarative, easy-to-read nature of SQL and mashes it up with the programmatic, highly extensible power of C#. This means you can write a really simple select statement, but then extend it with your own custom C# functions to pull off incredibly complex calculations over mountains of data.
Let's pull it all together. Section 6. The Complete Analytics System.
Let's quickly retrace the journey of our tiny data point through the seamless pipeline we've just built together. Step 1, it gets safely ingested and buffered by event hubs. Step 2, for immediate insights, it gets processed right away via Stream Analytics down the hot path. Step 3, at the exact same time, the Event Hub's capture feature saves it securely in the Data Lake Store for cold storage. And finally, Step 4, it gets analyzed in bulk alongside millions of other data points using Data Lake Analytics on the batch path.
And there you have it, the entire Lambda architecture brought to life using Azure Platform as a Service tools. But there is one final piece to this puzzle, Azure Data Factory. Because think about it. How does the highly refined data from those massive batch jobs actually make it back to the end user who wants to query it?
That is exactly where Azure Data Factory comes in. It acts as the grand orchestrator of this whole operation. Data Factory schedules the data transfers, reads those freshly calculated aggregate files out of the data lake, and automatically updates the serving layer, like your SQL database. It directly ties the batch layer to the final user queries, making sure everything stays perfectly synchronized without anyone having to manually step in. Which leaves us with this final thought. Every single day, more interconnected devices come online. The avalanche of data isn't just relentless, it's growing. By splitting the workflow into hot and cold paths, the Lambda architecture on Azure actually brings order to all that chaos. So I have to ask, as data creation accelerates relentlessly, can your current architecture survive without a split-path system? Think about that next time you look at your own data pipelines. Thanks for joining me on this explainer, and keep building.